If the government wants to find a crisis coming from a numerical simulation, there's a simulation guy that'll show it to them. And if there's another simulation guy who says, no, there's no crisis coming, well, he's not going to get his contract renewed. And the guy who says there's a crisis coming will get his contract renewed.
This is Climate Debrief, brought to you by the CO2 Coalition. I'm Angela Wheeler. We'll soon be talking with Dr. Wallace Manheimer. Dr. Manheimer is a Life Fellow of the American Physical Society and the Institute of Electrical and Electronics Engineers. He spent 34 years at the U.S. Naval Research Laboratory, serving as an ST-16 senior scientist for his last 14 years there. Now a consultant, he's authored more than 150 refereed papers on fusion, beams, microwaves, radar, and plasma tech. Since leaving the lab as a full-time employee in 2004, he has worked on his own scientific projects. One such project is fusion breeding, the use of fusion neutrons to breed fuel for thermal nuclear reactors. It's a pleasure to have you on Climate Debrief, Dr. Manheimer. Why do you compare the Scientific Society's statements on climate change to the foundation of a building, and what happens if that foundation isn't solid?
If you hear politicians, they always say that they've talked to scientists, and these scientists assure them that we have to change our energy structure in such and such a period of time. And the basic justification for that is the statements of the scientific societies. I'm actually a Life Fellow of both the American Physical Society and the Institute of Electric and Electronic Engineers, and they just have a lot of false statements. The American Physical Society is probably one of the least guilty, but they say that the recent heating that we see is absolutely unprecedented. And it's just not true. You can look at a thermometer graph and see that 30 years before that, there was another heating period, which was just at the same rate. Many scientists, myself included, have gone to these science societies and said, please change your statements. They make no sense. And we're always ignored. So I think that the thing to do is to really try to bring pressure on these societies from outside of the societies rather than from inside of the societies. And that's what I'm trying to do. I mean, I'm an insider as far as the two societies I mentioned, but I'm certainly an outsider as far as some of the other societies I'll mention. And I think that these statements that the presidents of these society makes are sort of like the foundation of this gigantic, I would call it a gigantic house of cards that we've built on the climate disaster which is coming to us. And I think they're analogous to the foundations of a building. And here's a picture of a building which doesn't have a solid foundation, and the thing collapses. Well, I think that the societies, if you can attack their statements and hopefully get them to change it, or if they won't change it, to get the world to ridicule them, I think that's the way to take down this whole gigantic structure. So in the paper that was on the first slide, I gave many, many examples of things that the society said which just weren't so. And they don't do due diligence. And I think that if you can tear down the foundation of these societies, you can tear down this whole, what I call the house of cards of the climate dilemma. So I see that. And I think that for people like the CO2 coalition, you know, we probably shouldn't be going to politicians. We should be picking more on people our own size. And these scientific societies are our own size. You know, the politicians aren't going to listen to us. The captains of industry aren't. We could go to Bill Gates and, you know, something caused him to change his mind recently, but I doubt if we had much to do with it. But I think by picking on these societies and trying to get them to act rationally, we can have a big effect.
Can you break down the average power usage per capita in different regions, like Americans, Western Europeans, Chinese, Indians, and Africans?
Well, sure, that's fairly easy to do. There's data for that all over the place. Look at the graph, and in the various colors are graphs of the various different places. Like the United States is this blue curve near the bottom. And you notice that the United States graph is not getting particularly thicker as you go from, say, 1970 to 2023. So you might think that our power hasn't changed, but it really has. We've changed from coal, which puts a lot of emissions in the atmosphere, to natural gas, which puts less atmosphere in. So for the same amount of atmospheric emissions, we're getting more power now in 2023 than we did in, say, 1970. But all of these places are trying to increase their power. The one that you should really take a look at is China. I mean, China now is putting more carbon dioxide in the atmosphere than the United States and the European Union put together. And I have an interesting experience with the Chinese. In 2009, I was at a science meeting held by the American Department of Energy, and there was a high-ranking member of the Chinese Academy of Sciences there, and he said, in 2000, the average Chinese uses 10% of the power that the average American uses. In 2009, which was when the meeting was, they used 20%. Now, as you can see, they're using like 35%. And after this Chinese official said that they're using 20%, the next thing he said was, and we're not going to rest until we use the same power per capita that the Americans do. And you can see that now they're up to about 35%. Other places that are greatly increasing their power is other parts of Asia. I think this dark green part, that's probably mostly Indonesia. It doesn't include India. Japan, I don't think, is particularly increasing its power. It's probably mostly Indonesia, Vietnam, the Philippines, Thailand, places like that. It's less visible for India, but they are certainly increasing their power too. So until nuclear energy is ready to substitute, perhaps an energy from now, fossil fuel is an absolute necessity for civilization. There's no substitution for it. And to bring the whole world up to Western standards, which the Chinese and the Indians are certainly doing all they can to do, would really mean that you've got to pretty much triple the power that we're using. And that would roughly bring the world up to maybe not American, but Western European standards, certainly. So let's see what some of these foreign leaders have to say about this.
How have leaders from less developed countries responded to calls for phasing out fossil fuels?
Let's take a look at Sultan Al-Jaber. He was one of the heads of the 2023 conference on the United Nations conference. I think it was held somewhere in the United Arab Republics somewhere. And he's not the president, but he was the head of the conference. And I basically regard him as a representative of 500 million people in the Arab world. And his statement is a fossil fuel phase-out would not allow sustainable development unless the world moves back into caves. Well, if you think there are a lot of Arabs and the 500 million of them that think this way, take a look at India. There's Indian Prime Minister Modi. He's the head of a population of well over 1 billion. And on November 21st, his statement was, the colonial mindset hasn't gone. We're seeing the path that made developed nations developed as being closed to developing nations. Well, if you want to look at another 1 billion people, let's take a look at Africa, which has 1 billion people in it. And the largest country in Africa is Nigeria, and the president is a guy named Bola Tinubu. I guess I'm pronouncing it approximately correctly. Nigeria alone has over 200 million people in it. In 2023, his statement is, Nigeria is an oil-producing nation and a developing country that needs revenue from fossil fuel for growth, development, and to reduce poverty. So these countries and these regions of the world are going to attempt as they see fit. There's no stopping them. Al Gore and John Kerry, or they fly over to these places in their private planes and they shake their finger at them, and maybe they'll have a conversation. But But they're not going to do what they say. The status of their people, the economy of their people is too important for them to listen to any of that. And they don't. And this is, I think, a fair sample of how the rest of the world views us.
Why is CO2 essential for plant life and all life on Earth? And how do greenhouses typically use it?
Carbon dioxide is essential for plant life and therefore for all life on Earth. I mean, if there are no plants on Earth, we animals wouldn't be able to live very long. Greenhouses typically use the CO2-rich atmospheres, often nearly as much as 4 times the ambient value, sometimes up as much as 1,500 parts per million, which is pretty close to 4 times the ambient value. People certainly walk into and out of the greenhouses without having any harm put to them. And it's essential because of what we've all learned. I think I learned it in grade school, is photosynthesis. And here's a little picture of it, but the chemical reaction is that you take 6 CO2 molecules, add 6 water molecules, and mix in some sunlight to energize it, and what you produce is a sugar, the most fundamental sugar molecule, which is the basis of all the other organic chemical reactions in every plant. And not only do they produce that sugar molecule, but they reduce, they emit 6 molecules of oxygen into the atmosphere. And like I said, the guys in the greenhouse with 1,500 parts per million, 4 times today's concentration of carbon dioxide, they walk in and out of the greenhouse all the time without anything happening to them. And recent calculations done in part by some of the members of the CO2 coalition show that even at 1,000 parts per million, it's a reasonable concentration for CO2. And if we, just a little calculation, if we triple the input rate into the atmosphere, we'd reach about 1,000 parts per million in about a century. So we can run on, and there's plenty of fossil fuel too, with these gigantic new gas plants, and with getting shale oil out. There's certainly plenty enough fuel to run it at, run the world's economy at 3 times the use of fossil fuel for a century. And there's plenty of time then to develop carbon-free nuclear power using both fissile and fertile material. And that's another topic, of course. But the main thing is there's no need to panic. We can do what we're doing. We're not doing any harm particular to the atmosphere. And these calculations on what 1,000 ppm will do are done by really some of the finest in our coalition, by some of the most knowledgeable and finest molecular physicists and radiation physicists in the world. So carbon dioxide doesn't do any harm. It might produce a very slight amount of heating, and people have calculated it, and it's just something we have to live with.
What specific claim from the American Meteorological Society's 2012 statement about the warmest years do you highlight, and how does it describe the period from 1997 to 2011?
This is just one of many, many errors in these statements of these science societies. This one is sort of typical. The actual recent statement is, and it's amazing, I couldn't believe it when I looked into it. I thought they would have modernized it, but apparently that same statement has been in their it has been their same statement for 14 years. They've never modernized it from 2012. At least that's the easiest one to find. Nevertheless, the 10 warmest years in the global temperature records up to 2011 have occurred since 1997, with 2005 and 2010 being the warmest 2 years in more than a century of global record. Well, that's actually a correct statement. But the question is, so it's the hottest in 100 years. What does that mean? What was it 200 years ago? What was it 500 years ago? And there's a lot of temperature measurements, and the ones with thermometers all show pretty much the same thing. Let me show there's one by NOAA. Look at the graph on the left, and if you look carefully, you can see the NOAA icon in it. And it's a very jagged curve, and this is only for the land area of the continental United States. The NOAAs do their measurements very carefully. We're probably the best and most careful measurement of temperature in the world. Well, you can see this over the continental United States from 2005 to 2025. There's no increase in temperature. It's just bounced around over the place all the time. If you look at it worldwide, there are lots of ways of doing it worldwide. Just get temperatures in every different country and hope they're all reading, hoping they're all normalized to the same thing. But I like the way of doing it by measuring with satellites. And here is a measurement of the temperature from satellites over the last 50 years, and that's as long as they've been doing it. And these were based on the work of Roy Spencer and John Christie of University of Alabama in Huntsville. They do see a slight warming. I mean, if you look at them, as of November 2025, the warming is about 0.5 degree centigrade. So there's some warming from that, certainly, but certainly not enough warming that we should go over a panic over it. I mean, that warming is probably beneficial. And I think what you want to do also is look at what the temperature was like in various historical times.
Can you describe the two temperature measurements you reference? One from NOAA for the continental USA from 2005 to 2025, and the other from Roy Spencer's UAH for global temperatures from 1979 to 2025.
Okay, well, my thoughts on it are that a lot of the reason that they say, and I didn't prepare any view graphs on this, so I'm not as prepared, but I think a lot of what they say is that they do numerical simulations. Now, I've spent my whole scientific career doing numerical simulations. It's very hard not to put the prejudice of the guy doing the numerical simulations. I would imagine that if you look at this temperature measurement from Roy Spencer, the space-based one, and you look at the temperature simulations, I would imagine that they would be predicting much higher heating than what was actually measured. Someone who's made two people who've made real publicly mentioned this many times, are both John Christie, one of the guys who did the space-based temperature measurements, and Stephen Koonin. If Stephen Koonin is anything, he's certainly an expert on numerical simulations. If the government wants to find a crisis coming from a numerical simulation, there's a numerical simulation guy that'll show it to them. And if there's another numerical simulation guy who says, no, there's no crisis coming, well, he's not going to get his contract renewed. And the guy who says there's a crisis coming will get his contract renewed. Well, maybe not now, maybe not in this administration. So I tend to believe more the measurements. The measurements don't indicate any climate crisis is coming. There's just no two ways about that. If the temperature increases a degree or so over the next century, a degree, 2 years, I think Judith Curry, another real, one of the real major leaguers, she used to be the chairman of the Earth Sciences Department in Georgia Tech, but ultimately she left. She just couldn't stand it anymore. That they weren't allowed to do the real science. They just had to get the simulations to show what the government wanted to see.
Thank you for joining us on Climate Debrief. Executive producer is Angela Wheeler. Producers, Ethan Oddie and Scott Wheeler. Video editor is Miles Morell. You can find more episodes of Climate Debrief at co2coalition.org.